Bam! Mr. Tarrou. In this calculus video, we're going to be taking a look at number 5 from the 2018 Calculus AB exam to help you get ready to get a 5 on your AP exam. We're going to have this question, which is 4 parts. I'll have a link to the timestamps, which allows you to jump ahead to the different parts of the video if you like. And you'll also find a link to the official AP College Board website where you can find a full PDF of these questions, a PDF of the scoring guidelines, a PDF of the master graders' comments of where students lost the majority of their points, and so on and so on. It's a great resource. So we're going to say here with this problem, part A is going to be about average rate of change. B is going to be about the slope of the tangent line for function f. We have C that's going to help us make sure we know how to find the absolute value on a closed interval. And then finally, D is going to be involving this graph over here. So let f be the function defined by the function here e to the x times the cosine of x. A says find the average rate of change of f on the interval from 0 to pi, the closed interval from 0 to pi. Okay, don't forget the average rate of change is nothing more than the slope of a secant line. So we're talking about y2 minus y1 over x sub 2 minus x sub 1. So we are going to figure out what f of pi minus f of 0 over pi minus 0 is equal to. And that is going to be equal to e to the pi times the cosine of pi. That takes care of the f of pi minus f of 0. Now don't be quick to think that this is just going to be 0, of course. The cosine of 0 may not be 0, it's not, and nor is e to the 0 power. All right, so what do we have? We have e to the 0 power is 1. Cosine of 0 radians is equal to 1. So we have e to the pi times cosine of pi minus 1 over pi, and that is our average rate of change on the interval from 0 to pi. Just checking our work here, and we are good to go. Part B coming up right now. Part B, what is the slope of the tangent line to the graph of f at x is equal to 3 pi over 2? So we went from being tested whether or not we remember how to find the average rate of change to can you find a derivative using, well, we have e to the x times cosine of x, so the product rule. We've got f prime of x. Product rule is the first times the derivative of the second. The derivative of cosine is negative sine, so negative e to the x times the sine of x plus the, let's see here, first times the derivative of the second plus the second times the derivative of the first. And we love the derivative of e to the x because it's just another e to the x. Now we're going to evaluate that derivative at the value of 3 pi over 2. So we're looking at evaluating negative e to the 3 pi over 2 times the sine of 3 pi over 2 plus e to the 3 pi over 2 times the cosine of 3 pi over 2. Well, the cosine of 3 pi over 2, that's 3 movements of basically 90 degrees. So we've got 1, 2, 3 pi over 2. The cosine there is equal to 0. So our second term is all equal to 0. And the sine of 3 pi over 2, rotating down 270 degrees, or 3 pi over 2 radians, gives us a sine value, a y value of negative 1. That negative 1 is going to get multiplied to the negative coefficient that we have here from taking the derivative of cosine and getting negative sine. So finally we have f prime of 3 pi over 2 is equal to just e to the 3 pi over 2 power. Let's go ahead and check our answers here. Yep, that is good. If you want to see, again, how these points are awarded for each of these parts, each individual free response question is a total of 9 points. You can check out the link to, again, the apcentral.college board website where you can download the scoring guideline, which will tell you the points and also, again, the grading commentary from the master grader, so you can see where the common mistakes are made. But that is our answer for part B. And it was 2 points. In this case, it was a point for writing the correct derivative out and a point for getting the correct answer. Part C coming up right now. Part C, we're going to find the absolute minimum of the absolute minimum value of f on this closed interval from where x is going from 0 to 2 pi. With your free response questions, and they give you these functions, whenever they start talking about a closed interval, nearly all the time, intermediate value theorem, extreme value theorem, mean value theorem. And here, they're giving us the closed interval on the same question where they're asking for the absolute minimum. Well, where do you find that? You find that by testing the function at the endpoints of those closed intervals, and then you also test where the derivative is either equal to 0 or undefined. Remember, finding extrema in terms of absolute max or mins is not the same as finding the relative extrema, where you need to talk about how the first derivative changes from positive to negative for relative max, or the first derivative changes from negative to positive for relative min, or maybe you're talking about the second derivative test where the first derivative is equal to 0 and the second derivative is greater than 0, or negative is less than 0. No, for an absolute max or min, all you have to do is test the function at the endpoints of that closed interval or at each of the critical values. So we need to find out where f prime of x, which remembering from part B, is equal to negative e to the x sine of x plus e to the x cosine of x. We need to figure out where that derivative is equal to 0 or undefined. Now, e to the x is defined everywhere, sine is defined everywhere, cosine is defined everywhere. This derivative is never going to be undefined. But as far as it equaling 0, that potentially looks like it could be quite difficult to solve. But when you have these more complex equations, you generally solve them by factoring. So let's factor out an e to the x. That's a common factor in each of these two terms and see what happens. So we take out our e to the x and end up with negative sine of x, yay, the air conditioner turned off, times the cosine of x equals 0. I know it's a little bit distracting with the audio and the video, but it's a necessity in Florida. Now we have e to the x as a factor. Well, forget that. E to the x is never going to be equal to 0. It's an exponential function, and it's, by the way, exponential growth. And the x-axis, or the line y equals 0, is acting as a horizontal asymptote there, so that's not going to be considered. But we can look at where is the sine, negative sine of x plus cosine of x equal to 0, or where is the cosine of x equal to the sine of x, so that when you subtract them, you get answers of, well, 0. That's going to occur, of course, at pi over 4 and 5 pi over 4. So our critical values are x equals pi over 4, x is equal to 5 pi over 4. That's our critical values as far as the first derivative is concerned. But with looking at the absolute minimum, on this closed interval, the other points that we need to test are x is equal to 2 pi and x is equal to 0. So let's get this derivative work out of the way and start analyzing the function f at each of these 4 values. So we have f of 0 is e to the 0 times the cosine of 0. E to the 0 is 1, cosine of 0 is 1. Boom. Now we're going to look at f of pi over 4. E to the pi over 4 times cosine of pi over 4 is square root of 2 over 2 e to the pi over 4. You can definitely see that AP is expecting us to know our unit circle as we do our AP test, of course. F of 5 pi over 4 e to the 5 pi over 4 times the cosine of 5 pi over 4. Well, that's going to be negative square root of 2 over 2 e to the 5 pi over 4. We're looking good so far for finding an absolute minimum, because you're starting to maybe look at some of these values and like, how am I going to find an absolute extrema without using a calculator? Well, we are looking for just a minimum, positive, positive, and right now, this is our only negative value. Now at f of 2 pi, we have e to the 2 pi times the cosine of 2 pi, which is e to the 2 pi. We have 1, 2, 3 positive answers and only 1 negative. This is, we do have f has an absolute minimum value of negative square root of 2 over 2 e to the 5 pi over 4 at x equals 5 pi over 4 on a closed interval from 0 to 2 pi. And you're not going to get a point for identifying this as your absolute min unless you do justify it. In other words, you're going to write a sentence that's going to explain your thinking of why you came to that conclusion. Our last part, part D, coming up right now. And finally, for part D, we are going to let G be a differentiable function such that g of pi over 2 is equal to 0. The graph of g prime, bam, we're finally going to use it, is shown. To find the value of the limit as x approaches pi over 2 of f of x over g of x, or state that it does not exist. Okay, so what is this problem going to involve? Well, the limit of a ratio, of course. And the limit as x approaches pi over 2 of f of x over g of x. Okay, well, they're probably asking this question for a reason. It's not going to come out super duper easy. The limit as x approaches pi over 2 of f of x over g of x. I admit, I used to write equals next to every limit statement that I would do in my work and teach in my class, and unfortunately I realized about a year later when I went to another AP training that if I write this and it turns out to be what it's going to be and I leave it like that, they're just going to stop grading and give you 0 points, okay? So what's going to happen? The limit as x approaches pi over 2 of f of x. Well, e to the pi over 2 is no problem, but the cosine of pi over 2 is 0. And we already were told that g of pi over 2 is equal to 0. So if you say, well, this is equal to this, and this is equal to 0 over 0, I mean, you might want to write, I mean, maybe you're going to write this initially, because a lot of times we analyze limits, you get real values, but this is a form of indeterminate, and that's not what this limit is actually equal to. It turns out that this one does have a real solution. It is not 0 over 0. This is a terrible habit, and I've been trying to break myself of it ever since I went to that additional AP training. Is it super picky, and do I hate it? Kind of, yes. You could kind of like maybe cross this out or something like that, or just take out the equal signs, and you can say like this limit is in the form of 0 over 0, and I've been told by trainers you can get away with that. But what they really want you to do on the AP test when you have this form of indeterminate is show that the limit of the numerator and the limit of the denominator separately are equal to 0. And I believe that's why they wrote this particular question. They got tired maybe of us high school teachers saying, well, in the form of 0 over 0 is okay, because here's what's going to happen. You can say that okay, well, we don't know what it is yet, but we do know it's indeterminate. So we're going to take this off because I've unfortunately not left myself a whole lot of room. And let's take the limit of the numerator. As the limit as x approaches pi over 2 of f of x, we can see what this is. This is, as previously discussed, an exponential function defined everywhere, cosine defined everywhere. The domain of this function is all real numbers. It's continuous everywhere because it's a product of two continuous functions. So the limit as x approaches pi over 2 of f of x is basically as previously stated, but I'll write it again, e to the pi over 2 times the cosine of pi over 2 is equal to 0. So the limit of the numerator as x approaches pi over 2 is 0. We've identified the limit notation, or the limit value for the numerator separately. Then the limit as x approaches pi over 2 of g of x. Well, here's where they're really making sure that you understood every little nuance and fact that you learned in AP Calculus. G prime of g, why do I keep saying prime? G of pi over 2 is equal to 0. Well, man, how much did I have to beat it over my kid's head in chapter 1, how a function's value and a function's limit value does not have to be the same as long as the left and right-hand limits are equal. The two-sided limit exists, but that could be a whole, and the function can be defined somewhere else. So just because we know that g of pi over 2 is equal to 0, that doesn't mean that we know what the limit as x approaches pi over 2 of g of x is equal to. It could be a function with a removable discontinuity, and basically like a piecewise function where then it just pops in another y value somewhere else. Okay, I mean, man, they are being particular on this one. If you don't catch back here, and I state this a lot when I have questions, when I see these FRQs with my class, how, hey, whenever they tell you that a function is differentiable, you're going to probably need to recognize that that function is therefore continuous. Normally it's for the application of intermediate value theorem or mean value theorem or extreme value theorem. But here, we're going to know that the limit as x approaches pi over 2 of g of x is pi over 2, 0, because g is continuous since it is differentiable. That's how you're going to come to the conclusion that the limit as pi over 2, as x approaches pi over 2 of g of x is equal to 0. So now we have the indeterminate form of 0 over 0. It's so much nicer just to write 0 over 0 and say, you know, in the form of, which allows you to then apply L'Hopital's rules. So we're going to apply L'Hopital's rule, L'Hopital's, which is going to be that we take the derivative of the numerator and the derivative of the denominator, making sure I've said that correctly, individually. So now with L'Hopital's rule, we're going to evaluate the limit as x approaches pi over 2 of f prime of x over g prime of x. Okay, well, f prime of x, evaluating it at pi over 2, is negative e pi over 2. I feel like I wrote this already, but since I'm erasing each part as I do each new part. Yeah, nope, I didn't actually. Okay, so the cosine of pi over 2 is 0, so that's gone. The sine of pi over 2 is 1, so we're looking at negative e to the pi over 2 power. And in the denominator, we have g prime, the limit as x approaches pi over 2 of g prime of x. Oh, they gave us the graph of g prime. And g prime of pi over 2 is equal to 2. And that is, making sure I'm not forgetting some kind of notation. Nope. Now, my students, who I constantly have to correct you on your notation of evaluating limits and L'Hopital's rule, the marking scheme says, by the way, this is a 3-point question, and if you write all these, you know, basically limit statements without the limit notation, you are going to get one of these 3 points, even though you knew exactly what to do. I'm Mr. True. Bam! Go do your homework and get a 5 on that exam.